You know how you can't really scroll through the news lately without seeing some wild weather event?
It seems constant, doesn't it?
Yeah, just this past April, parts of the U.S. got absolutely hammered. I mean, torrential rain, winds that felt like they could rip your roof off, and some really nasty thunderstorms.
Why?
It makes you wonder what's really driving all this.
Well, that's precisely what we're about here on the deep dive.
Trying to get to the bottom of it.
Exactly.
Yeah.
We sift through the noise to bring you the core understanding of what's happening. And today, we're plunging into a key player in a lot of these intense weather scenarios. Atmospheric rivers.
Yes, atmospheric rivers or ARs, and they aren't some, brand new phenomenon.
Right.
But their impact is definitely becoming more significant, especially when we factor in, well, climate change.
Okay.
And for you, our listeners, keeping abreast of current affairs, particularly if you're prepping for exams touching on geography, environment, or maybe disaster management.
Which many of our listeners are, especially for UPSC. Precisely. Grasping the fundamentals of ARs is becoming, I'd say, absolutely essential.
Okay, atmospheric rivers. It sounds, I don't know, almost mythical, doesn't it? Like a legend or something.
It does have that ring to it.
But in practical terms, what are these rivers in the sky actually about?
Well, the poetic description is surprisingly accurate, actually. Think of them like concentrated highways way up in the atmosphere.
Highways for water?
Exactly.
Yeah.
Transporting enormous quantities of water vapor. They start over warm, tropical oceans places with lots of evaporation.
Makes sense.
And these plumes of moisture, which are invisible, by the way,
All right, invisible.
they get steered towards land. The notorious Pineapple Express, which hits California,
Yeah, I've heard of that one.
that's a classic example of an atmospheric river in action. Brings a ton of rain.
Invisible rivers carrying that much water. It's almost hard to picture. Can you help us visualize the scale? Like, how much moisture are we talking about?
Yeah, let's try. According to NOAA, these ARs can stretch for, say, up to 1,600 kilometers.
Wow, okay. That's huge.
Huge, roughly Delhi to Kolkata, give or take. And they can be 400 to 600 kilometers wide.
So wide bands, too.
Yep. But the really staggering part is the water content. A typical AR carries about the same volume of water as flows out of the mouth of the Mississippi River, on average.
The whole Mississippi.
On average, yes. Now, here's where it gets, well, really interesting. The strongest atmospheric rivers, they can transport up to 15 times that amount.
15 times. That's unbelievable.
It's a phenomenal amount of water, enough to potentially flood a major city under several feet of water pretty quickly.
Wow. 15 times the Mississippi. That really puts the potential impact into perspective. Now, I've heard these ARs aren't all, the same level of threat. They're categorized.
That's right, and it's a critical distinction.
Okay.
Scientists use a system, Category 1 to Category 5. It's based on their strength, basically,
Yeah.
how much water vapor they carry and for how long.
And then what kind of damage they might do.
Exactly, the potential impacts. It helps us understand they aren't all just about destruction.
So it's not just constant flooding and devastation. There's nuance there.
Absolutely. A Category 1 AR, that's considered weak. It's actually primarily beneficial.
Beneficial. How so?
Well, it can gently replenish soil moisture, great for farming, and help with drought recovery, like a good, steady soaking rain.
Okay, like a welcome shower.
Pretty much. A Category 2 or moderate AR is also mostly beneficial. Helps refill reservoirs, groundwater, that sort of thing, especially after dry spells.
This just sounds pretty good.
It generally is. Though even these weaker ones, if the rain hangs around too long or the ground's already soaked,
You could still get some problems.
yeah, maybe some localized flooding or minor mudslides. Nothing too widespread usually.
Okay, so the lower categories are more like a needed drink of water. When do things start to get dicier?
When I get to Category 3, so that's classified as strong,
Right.
here you start seeing a more delicate balance. Still potentially good for drought relief and filling reservoirs.
Right.
But the heavier rain starts to noticeably raise river levels. The risk of flooding increases, especially in areas with poor drainage or steep slopes.
Okay, so the hazard level is definitely ticking up.
It is. And then you move into the zones where the risks really start to outweigh the rewards.
Category 4?
Category 4, considered extreme. Any benefits are kind of secondary at this point. The extreme rainfall is very likely to cause widespread flooding.
Rivers overflowing their banks, that kind of thing.
Yes, potentially inundating surrounding areas. And then there's Category 5, exceptional,
Oh, worst one.
overwhelmingly hazardous. The prolonged intense rain often leads to catastrophic flooding, devastating landslides, infrastructure failure,
And tragic.
tragically, often significant loss of life. The economic costs can just skyrocket easily into the billions. So yeah, the category system is crucial for understanding the whole spectrum.
That's much clearer now, thanks. It really highlights the variable threat. Okay, so we have these huge, often invisible water vapor conveyors. What's the engine? What makes them go, and how do they dump all that moisture?
Right, the journey. It starts over those warm tropical and subtropical oceans we mentioned.
Like the Pacific or Indian Ocean?
Exactly. The Central Pacific, large parts of the Indian Ocean key source regions. High sea surface temps mean lots of evaporation.
Okay, step one, evaporation.
Step 2. These low-level jet streams kick in. Think of them as express lanes for air, lower down.
Guiding the moisture.
Precisely.
Yeah.
They spear this concentrated moisture from the tropics towards the mid-latitudes where places like the U.S. and India sit.
Got it. And step 3, the release.
That happens when this moist air hits something that forces it upwards, like mountains.
Ah, or a graphic lift.
Exactly. Or even colliding with colder air masses at weather fronts. As the air rises, it cools.
And cool air can't hold as much moisture.
Right. So the invisible water vapor condenses, turns back into liquid water droplets or ice crystals, like steam hitting a cold window.
And then it falls as rain or snow.
And that's your precipitation. So the
Yeah.
terrain, the mountains, the existing weather patterns, they're crucial triggers.
So the shape of the land itself helps wring out the atmosphere, in a way. That's fascinating. Now, we started talking about the U.S., those April headlines. But you mentioned India. Is this mainly a problem for certain spots, or is it bigger than that?
Oh, it's definitely a global thing. The Pineapple Express gets a lot of attention, sure.
Because it hits California.
Right. But atmospheric rivers are responsible for a huge chunk of water vapor transport globally. Over 90% of the total poleward movement of water vapor in the mid-latitudes.
90%. Wow.
So when these ARs make landfall, basically anywhere, they have the potential to unleash really significant, often extreme precipitation.
Okay, let's zoom in on India then, especially for our listeners, maybe prepping for UPSC exams, following current events closely. What's the specific connection? How significant are ARs for India?
This is where it becomes particularly relevant, I think. There was a major study looking at AR events affecting India from 1951 to 2020.
Okay, quite a long period.
70 years. They identified 596 major AR events.
That seems like a lot.
It is. And here's the kicker. Over 95% of those happened during the summer monsoon season.
Wow. Almost all of them during the monsoon.
Yeah, which is, as you know, crucial for India's water and agriculture,
Sure.
but also the most vulnerable time for flooding.
That suggests a really strong link, doesn't it?
A very strong link. The study also found a powerful correlation between these AR events and major flood disasters in India.
How strong.
Get this. 70% of the major flood events between 1985 and 2020 were associated with ARs making landfall.
70%. That's huge. So events like
Like the catastrophic 2013 Uttarakhand floods, the massive 2018 Kerala floods, even the big South Asian floods back in 2007.
So these weren't just random heavy rains. ARs were often the driver.
Often the underlying mechanism, yes. These intense surges of moisture delivered by atmospheric rivers.
Those were such tragic events, and it sounds like this isn't just, history. Is the pattern changing?
Well, unfortunately, the data points to a concerning trend.
Which is?
The frequency and severity of ARs hitting India seem to have been increasing in recent decades.
Really? Where are particularly?
Especially over the densely populated Indo-Gangetic plains and also across peninsular India.
And the result is?
More frequent, more intense episodes of extreme rainfall, which, as we've seen, can lead to significant destruction, tragic loss of life, both human and animal, and major economic disruption.
So for someone studying for exams, understanding this increasing trend and its impacts is pretty vital.
Absolutely crucial, I'd say.
This paints a rather concerning picture for the future, and it leads inevitably to the big question lurking in the background. Climate change. What's its role here?
Climate change is acting like a significant amplifier. It's turbocharging these things, basically.
How so?
It comes down to basic physics. Warmer air holds more moisture.
Right, I've heard that statistic.
For every 1 degree Celsius increase in temperature, the atmosphere can hold about 7% more water vapor.
7% more fuel for these rivers.
Exactly. So, as global average temperatures keep going up, the atmosphere can carry even more water. This means ARs can become potentially much more intense just carrying a heavier load of moisture.
So these rivers in the sky are literally getting bigger, wider, wetter because of warming.
That's what the projections suggest. Longer, wider, and overall more intense in terms of the water they transport.
And the consequences.
Well, some climate models project a potential doubling in how often the most extreme AR events happen,
Doubling.
which would naturally mean a big jump in flood risks, especially in areas already known to be vulnerable.
That's a critical factor for long-term planning, infrastructure, disaster readiness.
Absolutely. It has huge implications.
Okay, so let's try to boil this down. For you, our listener, what are the absolute key takeaways from this deep dive? What should we really remember about atmospheric rivers?
Okay, key points. First, understand the basic definition. These long, narrow corridors of intense water vapor transport, starting in the tropics, carrying huge amounts of moisture.
Invisible rivers, massive scale. Got it.
Second, their dual nature. They can be beneficial, bringing needed rain, fighting drought,
Right.
but they're also a major hazard, capable of causing extreme rain, floods, landslides, especially the stronger categories.
Benefit and risk depends on the intensity.
Right. Third, the climate change link is critical. Warming is making them potentially stronger and more frequent.
Amplifying the hazard.
Precisely. And fourth, specifically for India, remember their strong connection to the monsoon and major flood events.
Like Uttarakhand, Kerala.
Yes, and the concerning trend of them possibly increasing in frequency and severity, particularly in vulnerable areas like the Indo-Gangetic Plains.
That Indian context is really important for our audience.
Very important.
So as we wrap up this deep dive, here's something to think about. Given this trend, more frequent, more intense ARs, what does that really mean for how different regions, particularly a complex place like India, need to plan? How do they manage both the growing disaster risks and their vital water resources?
It's a huge challenge, isn't it? Balancing the risks and the resource management.
Definitely a tough question. No easy answers, but one that needs serious thought.
Absolutely. And for those of you really focused on your UPSC preparation,
Yes.
this topic is gold. It cuts across geography, environmental science, current events, disaster management.
So highly relevant for prelims and mains.
Extremely relevant. Understanding air dynamics gives you valuable context for analyzing a whole range of issues.
Good point. Well, if you found this exploration helpful and you want more deep dives into complex topics like this,
Please do like and subscribe.
yeah, your support really helps us keep doing this. And if you have questions from today or ideas for future topics, please drop them in the comments below. We love hearing from you.
We really do.
And just that final reminder, the information we discussed today draws heavily on reporting and analysis found in the Indian Express.
A key source for staying updated on these kinds of developments.
Indeed. Thanks so much for joining us for this deep dive.